Afternoon, folks. We're back again on the second part to simultaneous equations. Let's see if we can close questions 6 up to 10. So let's start. Question 6. Going to maintain our approach to a linear comparison. You can see that these two signs, they only differ, the variable y differs in terms of signs. So it means we can sum and eliminate what's like. So 3x plus x gives us 4x minus y plus y gives us 0, so it's eliminated. 2 plus 6 gives us 8, and I divide both sides by 4. My x is actually 2. So I'll pick the first equation, which is saying 3x minus y equal to 2. But I know I have the value of x here, so it's 3 times 2. The value of x minus y equal to 2. When I simplify, it's 6 minus y equal to 2. Therefore, my y is actually 6 minus 2. So y is 4. I'm moving to question 7. And when I try and do a linear comparison, I can see that here we have exactly the same variable and coefficient, so we can eliminate it by subtracting. So when I subtract column wise, I'm going to get 4 minus 2x, that's 2x, 3y minus 3y, it goes away, equal to 17 minus 11, it gives us 6. Therefore, when I divide both sides by 2, actually my x is 3. Then let me pick the first equation, which is saying 4x plus 3y equal to 17. But I know I've got the value of x, so x is 3, so 4 times 3 plus 3y equal to 17. Therefore, 3y is equal to 17 minus 12. And y, actually when we divide both sides here, y is equal to 5 over 3. Then moving to number 8. Number 8, we need to formulate equations here. A bag contains 10 coins made up of $1 and $2 coins. We don't know how many $1 coin we have, how many $2 coin we have. But what we know is dollar and $2, they are not the same. So I can refer to this as X and this as Y. But what we are told there is if we add all of them, they give us 10 coins. But we are told if we combine their values, giving us 14. But if I check carefully, when we come to the value now, we are saying x plus 2y, because this time around is the value, it gives us a 14. And when I do my comparison, x is the same here, y. So if I do linear difference, that's x minus x goes away, y minus 2y gives us minus y, and 10 minus 14 gives us minus 4. Therefore, the y coins, they are 4. And if they are 4, I can come to say x plus 4, that gives me 10. So the x coins, they are actually 6. And if we say 6 plus 4, in terms of number of coins, it gives us 10. And when I double the value, because the y coins, they carry a double value, so it gives me 14. I think those are the values of x and y. Then next there, we have a total of 50 animals where we have chicken and goats. But now we are told chickens have got 2 legs and goats have got 4 legs. So the total legs that we find here, they are 140. So we can come to say, well, if we choose our variables to be like this, we can come to say 2 legs from goats, 2 legs from chicken, 4 from goats. So you can formulate an equation to say that 2c plus 4g, the result is 140. And we come back again and say chicken plus goats, the result is giving us 50. So if I choose, I can come to say, but because we used chicken, and here we are simply saying, but if we add chickens and goats, the result is 50. Now, we want to do an elimination here. So if we don't mind, we want one point to be the same. Or we can use substitution. When we say substitution, either of the variables, like c here, we can say c is equal to 50 minus g. So where we have got C here is the same as 50 minus G. So I'm allowed to come and proceed with my calculation here to say, but 2 instead of C, I'm now saying 50 minus G plus 4G, it gives me 140. When I expand the brackets, 2 times 50 plus 100, 2 times minus G is minus 2G plus 4G equal to 140. So these are like terms I can simplify. It gives me 2G equal to, when I transpose there, I get 140 minus 100, which is 40. So when I divide both sides here, I end up getting my cos being 20. Now that I've got cos, I can come back to this equation, which is a bit simpler, to say if I add chickens and goats, my result is 50. So C plus G is 50, but the G is unknown, so it's C plus 20. I get 50. So when I do the transpose, it takes me to C being equal to 50 minus 20. Therefore, C is actually 30. Then moving to the last problem there, where we can solve again by elimination. And this time we want to do elimination using substitution. So I can take this second equation and say, but if I make x subject of formula, it's the same as 1 plus y. So it means on the first equation, where I have x is the same as 1 plus y. So I can choose to say from first equation, y equal to 5 minus 2 times, where is x is 1 plus y. And when I expand my brackets, I have 5 minus 2 minus 2y. And when I collect like terms together, in other words, if I transpose these 2y, I end up having 3y being equal to 5 minus 2, which is 3. And when I divide both sides by 3 to get the value of y, y is actually 1. So I've got the value of y. Let's see if I can find the corresponding value of x. So I can pick this second equation that I used to eliminate to say, or even the one that I rearranged to say, but if x is equal to 1 plus y, y is known is 1 day, then it follows that x is 1 plus 1. Therefore, our x is actually 2. So I found my values of x and y. I think that's it on equations for Form 2. Thank you, folks.